Hello everybody, we're back with another visual pattern challenge. So here is our funny looking pattern today, and it's already labeled for us: step 1, step 2, step 3. The challenge here is to use your visual intuition to predict the number of squares, blue squares, in step 4. So how many blue squares would there be in step 4? And if you can do that, see if you can predict how many in step 43. And along the way, can you write an equation that could be used to predict the number of blue boxes in any step at all? So that's the challenge. If you'd like to accept it, pause the video, see how it goes. All right, well, let's start by getting some visual intuition about this pattern. I'm seeing this sort of hollow box of blue squares in step 1, and I see that same thing here in step 2. And what's been added looks like just a box here, a box here, and a box here. And then, oh yeah, it looks like these sort of arms or tentacles that started in step 2 just get one longer in step 3. So it looks to me like they're adding 3 boxes in every step. And if I were to predict step 4, I would add a box here, add a box, whoops, I guess it goes down here, add a box down here, and add a box here. And that would give us, let's see, 6, 7, 8 from the original 9, 10, 11, 11, 12, 13, 14, 15, 16, 17, unless I miscounted. I think it would be 17. So we'll put that up there for now. We'll change that if we were wrong. But let's analyze the numbers here for the whole pattern that we've got. I'm going to make a chart with the step number and the number of squares. So in step 1, that's 6, 7, 8. So 1 has 8 squares. And then in step 2, we just add 3 more. So that should be 11. And in step 3, we add 3 more. So that should be 14. And in step 4, we add 3 more. So that should be 17. That is what we came out with. So this pattern of adding 3 every time supports that 17. And then we always look at the difference between the steps. So 11 minus 8 is 3. 14 minus 11 is 3. 17 minus 14 is 3. Maybe this is obvious to you already. If we're adding 3 every step, the difference between each step should be 3. And this verifies it. Well, if you get the same number for differences between the steps, it is a linear pattern. And a linear pattern means we can use the linear equation, the equation for a line, it's supposed to be an m, to model this. So y equals mx plus b. M is the slope, or in the case of a pattern like this, that means the rate of change from step to step. So it's changing by 3 each time. So our m is 3. So I've got y equals 3x. Now x is going to stand for the step number. So you'll plug in the step number and calculate how many squares there are. Y is going to give you that total number of squares. And this part, this plus b, that's the number we'll have to add to make sure it comes out with this particular pattern. Let's just try it. In step 1, we would have y equals 3 times step number 1. And if that was all the equation, we'd predict 3 boxes in this step. But there are 1, 2, 3, 4, 5 more boxes than that. So I think to make this come out, I have to add 5. And that means to our equation, we're going to add 5. So b turns out to be 5. I think. Let's test this in step 2. In step 2, we would say y equals 3 times step 2 plus 5. And 3 times 2 is 6, plus 5 is 11. Yeah, that's how many there are in step 2. How about step 3? Y equals 3 times step 3 plus 5. 3 times 3 is 9, plus 5 is 14. Yeah, that's how many there are in step 3. So this equation looks pretty good. So I'm going to jot that down here. Y equals 3x plus 5. Now, all we have to do is find how many there are in step 43, and we can use this equation to do that now. So y equals, and what we'll do is plug 43 in for x. 3 times step 43 plus 5. All right, 3 times 43, well, 3 times 40 is 120. And 3 times 3 is 9, so that's 129 plus 5. So that should be 134 blue squares in step 43. Well, how did that go for you? Did you get the number in step 4? Did you get the number in step 43? Let me know. Thanks, everybody.